Hello everyone, welcome to your own YouTube channel where you can ask the questions and can also reply to the questions which are previously have been asked by someone else. Our comment section is free for you and we are waiting for your views. So today we are going to tackle one of the most common DSA problem. Its name is container with most water. And this problem is described as you are given with an integer array height of length n. There are n vertical lines drawn such that the two endpoints of ith line I, 0 and I, height I. Find the lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So let's now move to the whiteboard to understand what does this mean. According to this problem, we are given with a integer type array containing a few of the integer values. These given values are the heights of the lines which will form a container with x-axis. So suppose here a integer array given height, its first element is 1. So the length of the first line will be 1 unit. The second element is 8. So the length of second line will be 8 unit. 4, 5, 6, 7, 8. The third element is 6. The length of the third line will be 6 unit. Similarly 2, then 5, 4, again 8, 3 and then 7. Now these lines will form a container with the x-axis. Wait a second. Here. The x-axis is this. And if we take any of the two lines, suppose I am taking this line, second, and the last line, they can form a container with x-axis. You can also look that the container which is looking like here, starting from here and going here. Now, let us understand one more thing. Suppose if I am having a container whose shape is looking like this, it is having one side height is higher than the other side, and if I start to add water inside this container, I will start to add water from here, and once I reached to the level of the lowest line, if I add continue to add more water, it will start to release the water which is stored inside it, because the smallest line is working, or the height or the side of the container which is minimum is working as a constraint. It is stopping us to store more water inside the container. Similarly, in our problem, we have to find the area which can store the maximum water, and it is found by only two lines with the x-axis. So if we take the second line and the wait if we take this second line and the last line and form a container with x-axis, it can fill water, we can fill water in it till here only, means till here only. After that, if we add any water inside this container, it will start to flow outside, because the height of this line is 7 unit only, whereas the height of this line is 8 unit. But we don't see the height of the largest line. We are seeing here the height of the smallest line. So we will take this 7 and will find the area of this container. So if we find the area of this container, how we can find? In our school days, we have studied a formula of area of rectangle. Area is equals to length into width. So its length is the, okay, wait a second. Its length will be the smallest line, and its width is this gap. How we can find this gap? Here, if we see in the array, the index of this first element is 0 and the index of this last element is 8. Similarly, the index of the second element is 1. Now we are taking this 8, means the second element and this last element. Now to find the distance between these two elements, or the gaps between these two elements, we can simply minus the left side element with the index of right side element. So the index of right element is 8 and the index of left line or the left element is 1. If we minus it from here, it will come out to be 7. So now if we try to find out the area of this container, okay, this container, then its area will come out to be, its area will come out length we will take the minimum, the length of the smallest line. So the smallest line length is 7 and the width we have found out from here, it's also 7. So 7 into 7, it's 49 square units, it will be the area. And now what we have to do, we have to find the maximum area which can be formed by two lines. This is the area formed by this second element and the last element. Now suppose, let me erase this all thing. Wait a second. Previously we have found the area of this container, means which is formed by this second line and this last line. Its area was coming out to be 49 square units. Now if we are taking this line and this line, how much its area will be? So similarly, we will take the length of the smallest line. The length of this smallest line is, I think, 5 units. Yes, the length of this line is 5 units. And we have to find the width, means this gap between these two units. We can see the distance between these two lines is 2 units. So if we multiply them, it will come out to be 10 square units. So the area of this container is 10 square unit, whereas the area of this container is 49 square unit. Now we have to do this same process for all the containers which are possible to be formed with these lines, and we have to find the maximum area which can be formed by any of the two lines. So if we compare these two values, 49 is bigger than 10, so we will ignore this container, we will proceed with this. Similarly, we can find the area of the biggest container. So how we can do this? Think here. So now the problem is this, how we can find the area between the two lines or the maximum area which can be formed by any of the two lines. So suppose this array here, it is given like this. Now can we use two pointer approach? Now if I initialize a pointer, if I initialize a pointer p here and a pointer q here, now if I try to find out the area which can be formed by these two lines, the length of first line is 1 and the length of the last line is 7 units. Now if we try to find out the area in between these two lines, what we will take as the length, the smallest line. Here the smallest line, we will compare these two values. The smallest line is 1. Now the distance in between these two lines we can find out by subtracting the index of the element, that p pointer, from the index of the q pointer. The index of pointer q is 8, the index of p pointer is 0. So if we subtract, it will come out to be 1 into 8. It will come out to be 8 square units. Now we have find out the area in between these two pointers. Now we can store this area into a variable. Suppose if we have created a variable max area, we can store there. This is the first area. Now what we will do, we will advance the pointer whose length is minimum among both of the two. So if we see, the length of the p pointer is 1, whereas the length of the q pointer is 7. So the minimum in both of them is 1. So we will advance this p pointer. Now this p pointer will come here. Now what we will do, we will repeat the same process and we'll find the area now. So now the area will come out to be the length will be the element whose height is less than the other, and the width in between those two lines width we can find out by the index of the last element minus the index of the left element. So 7 into 7, it will come out to be 49. Now we will compare the max area which we have stored it using the previous calculations with this area. Here 49 and here it is 8. We will compare, we will find that 49 is greater than 8. So our max area is less than the area which we have found. So we will update this max area. Now this max area will update to 49 from 8. Now again we will update the pointers. Now which pointer we will update? We will update the pointer whose length is minimum or whose length is less among the two pointers. Here the pointer P is having the length 8 unit, whereas the pointer Q is having length 7 unit. So we will update this pointer. Now this Q will come up to here. Now again we will repeat the same process. We'll find the area in between these two lines. Now the area, first the length will be the height of the minimum, means the height of the element whose length is whose value is less, and the width will be this gap will be the index of rightmost element minus the index of the leftmost element. When we multiply them, it will come out to be 18. Compare it with the max area is 49 and here the area is 18, so max area is greater than the area, so we will leave it as it is. Now we will again update the pointers. Now which pointer we will update? We will update the pointer whose value is less. Now this time P pointer is having the value or the length 8 unit. The pointer Q is having the length 3 unit. We will update this Q pointer from here to here. Now to find the area, again we will find the area. Here now this time both the values are same, so we can take any of the values. 8 into distance in between them. This time the index of rightmost element is 6 minus the index of the leftmost element. 6 minus 1, 8 into 5, it will come out to be 40. Now 40 is less than the max area is 49 and the area is 40, so we will ignore it as it is. Our max area will remain same as 49. Now we have to update the pointers. Now we will update pointer. Now this time the problem comes because both the values are same. So in this case we can update any of the element or any of the pointer. So if I update this Q pointer, it will come out to here. Now we will again find the area. Now the area will be the length of minimum element 4 into the distance in between them. The distance we can find out by the index. The index of 4 will be 0, 1, 2, 3, 4, 5. 5 minus 1. The area will come out to be 16. We will compare this 16 with the max area. Max area is 49. 16 is less than 49. So max area will remain same. And now we will update this area. Means we will update the pointers first. For updation of pointers, we will update the pointer whose value is less. So we can see P pointer is having value 8, whereas Q pointer is having value 4. So we will update this Q pointer from here to here. Now we will find the area. Okay. Now to find the area, we will take the length. We will take the minimum value among both the pointer, and we will find the width using the index of rightmost element minus the index of leftmost element. 5 into 3, 15. 15 is less than max area 49. So we will remain the max area as it is, and we will update this area by updating the pointers. So now we have to again update the pointer. The pointer P is having value 8, Q is having 5. So we will update the pointer with the minimum value. Q is having 5, Q will come out to here. Now we will find the area similarly again. Take the minimum value, find the width using the index 3 minus 1, 2 into 2, come out to 4. 4 is less than max area is 49. We will remain the max area. We will update the area after updating the pointer. Again, the pointer which is having minimum value will be updated. Pointer P is at value 8. whereas the value at pointer q is 2. So pointer q will be updated from here to here. Now we will find the area again. We will take the length of minimum element 6 and we will find the width using pointer index 2 minus 1. 6 into 1, 6. 6 is less than 49, so we will remain this 49. This means this max area as it is. Now if we try to update any of the pointer, if we increase the length of pointer p or if we decrease the value of pointer q, the pointers will point to the same value and the length in between them will become 0. So now here our iteration will stop because we have searched for all the possible cases and we have find that the maximum area which can be formed by the two values in this given array is 49 only, and which is formed by this second value which is at the index 1 and the last value. I think okay, this had formed this max area container. So this is what we have to do. So let's try to code it out. We have seen that we were using two pointer approach to solve this problem. So our code will start with the initialization of both the pointers. So I am initializing here a pointer named as left at index 0 and another pointer named as right at the last index, height dot length minus 1. Now we were using another variable max area which was storing the maximum area found by us. Now we will start a while loop. It will run till left is smaller than right. Now inside this loop we will first find the width, and width is equals to right minus left. Now we'll find the current area. How we can find? Firstly, we have to find the minimum among the values at pointer left and pointer right. Height left comma height right. This function math.min will find the minimum among both the values, and now we have to multiply with the minimum value with the width to get the current area. Now after getting the current area, we have to update the max area if this current area is greater than max area, or in else condition we will remain this as it is. So we are using here math.max function to find the maximum in between max area and the current area. Now we will update the pointer. For updation, we will check if the value at left pointer is less than the value at right pointer, then we will update the left pointer, or in else condition or in any other condition we will decrement this right pointer, and in last we will return the max area. Now let's run this code. I hope this should run perfectly. Okay, this is, you can see this is running perfectly, and you can also submit this from here. Okay, let's see. Okay, you can see here this code is running perfectly. If you found this information helpful, then please like this video, subscribe our YouTube channel, and share this YouTube channel with your colleagues and the fellow coders.